This problem is similar to the one before, but notice that instead of having this be a 1, it's a z, where z is any non-negative number. So now this is going to be an integral that depends on the parameter z. So let me just go to Desmos to sort of illustrate what's going on here a little bit, and then I'll come back to this to actually do the computation. So this is the same region as before. This is x plus y. Actually, this is, now it is, just zoomed way out. This little region right here is the part of the first quadrant that is below x plus y is equal to 1. And as z gets bigger and bigger and bigger, we get a bigger and bigger region. So notice that as z gets bigger and bigger and bigger, we get more and more of the first quadrant. Okay, so as z goes to infinity, these integrals over this region right here, over this triangular region, go to the integral over the whole first quadrant. So this is one way to compute this improper integral, as we will see. Okay, so if we just set up the integral, similar to what we had before, x is going to go from 0 to something. We'll figure out what the upper limit is in a minute. And then y is going to go from 0 to z minus x. So let me sketch a little picture of what's going on here. So this is the x-axis. This is the y-axis. This is the line x plus y is equal to z. We're doing the y integral on the inside, so it means we're going to have the vertical lines like this. Okay, and we know that y is going to go from y equals 0 to z minus x because that's the equation for this line right here. We know x goes from 0 to this point. Now this point is just the intersection of the lines x plus y is equal to z and y is equal to 0. So in other words, if y is equal to 0, at this point y is equal to 0 and x plus y is equal to z, that means x is equal to z. So that's z, and then this is e to the minus x minus y dy dx. And again, we're just going to look at the inside integral. This is the outside integral is still x equals 0 to z. The antiderivative of this is e to the minus, is minus e to the minus x minus y. And we're going from y equals 0 to y equals z minus x. So this is e to the minus x. Sorry, this is actually plus, isn't it? E to the minus x plus 0 minus e to the minus x plus z minus x dx. This is the integral. Let me just write this a little bit. X equals 0 to z e to the minus x minus e to the minus z dx. Okay, e to the minus x, the antiderivative of this is minus e to the minus x. So this is e to the minus 0 minus e to the minus z. And then this is a constant as far as x is concerned. So this is just minus z e to the minus z. And so this is 1 minus 1 plus z over e to the minus z. Well, I did not mean to do that, but you can just back up the video for a little bit. So the integral was 1 minus 1 plus z over e to the z. And as z goes to infinity, this goes to 1. So then the integral of e to the minus x minus y over the first quadrant is equal to 1.